All right, so this one is going to be talking about cross sections of three-dimensional objects. So a cross section is basically it's kind of like a 2D picture of an object. So, like for example, a lot of times we think of a prism, for example. Let's talk about a rectangular prism. So, rectangular prism. If we take a cross section of a rectangular prism, a lot of times when we're talking about a rectangular prism, you're like, oh, well, it's a rectangle, right? We can take the front cross section, cut through, but cross sections get a little more specific. You can do cross sections anywhere. You can do a cross section down the middle. It's kind of like having a 2D image and what goes on the piece of paper. But you can also do cross sections diagonally, which would kind of make it look a lot longer. Or what if you do cross sections on the corner? On the corner of this, you would end up getting something like a triangle because you're cutting right here at an angle, which makes a little corner. So a cross sections, um, they seem very basic, but you do kind of have to think about it a little bit. And they're going to give us some tools to work with it as well. So let's get into cross sections. So as always, you can watch the videos on your own. Some of them I know are just regular videos. So cross section, for example, if you're cutting cheese, that two-dimensional shape in the cheese would look different if you cut straight down versus cutting at an angle. So let's kind of get into this. So cross section of a right rectangular pyramid, and by right it just means they meet right in the middle. So um, every one of these sides is going to be equal essentially. So let's take a look. So we're going to be looking at this. So this is saying like, hey, Ryan is replacing the ornamental pyramids on top of the fence. So there's pyramids on top of his fence, basically, yard. So we have this pyramid right here, and it's right. This is actually a better definition than what I did. 90 degrees. So if you had it kind of off to the side, a pyramid like this, um, it's not for, oh my gosh, computer's going slow. Sorry about that, guys. I'm not sure why this isn't erasing right now. Hmm, what is going on here? I don't know why it's not erasing. So, it's basically just saying that the top of the pyramid is at a 90-degree angle from all sides. Let's see if it erases on this. It erases just fine here. I don't know why it's stuck there. Oh well. So let's get into this. So this is saying on top of the post, back into shape. So now we're going to say Ryan slices um, the pyramid and gets a cross section parallel to the base. So let's see if I'm able to write in it again. The worst case, at least it erase it. So parallel to the base. Well, the base we already talked about in the last videos, that it's the bottom part right here. So if it's parallel to the base, when we do our little sheet of paper, what shows up there? Well, it should show up with the same shape as the base, just smaller, right? So we're going to say that it's a square base. So if it's a square base, then we're going to say it the cross section. The cross section is also a square, but smaller than the base. Now the next one we say like, oh, so now he saws off more wood from the pyramid. The cross section moves closer to the base. What happens to the size and shape of it? So just because it's going closer doesn't mean the shape's changing, right? Like he's just gonna cut a little bit lower So that means that the shape, oh my gosh, I don't know why it doesn't like deleting. So we're going to say that the shape doesn't change. So the shape remains the same, or you can say it doesn't change. The shape remains the same, but since he is cutting closer to the base, it becomes larger. And if I have typos, guys, I'm sorry. It's just that my keyboard is not facing my monitor at the moment, just because of how I have the laptop set up. Um, so the shape remains the same, but since he's cutting closer, it becomes larger. And I'm sure you guys can word that a lot better. All right, so the next one, imagine the pyramid. Imagine slicing the pyramid with a plane parallel to the base passing through the topmost point. So, because I can't erase on the other one, so we have this thing, this pyramid. Oh my gosh, this is the worst pyramid I've ever drawn, guys. I'm so sorry. We have this pyramid, and it's at the very, very top. What does a cross section look like? Well, since it's at the very top, it should be a dot. Like, you're cutting the very top, so um, this is a dot um, because um, it is the very top with, because, well, I'm just going to say because the very top is a point. So it looks like a dot in the cross section because it's only a little point. It's not flat up there. They all meet at the point, right? This is because all the sides meet at a point. And honestly, you don't even have to write that. I'm just writing it because I feel like you have to write something else. You can always compare your answer to the answer Edmentum gives you afterwards, and you can kind of judge it from there. So they're saying the cross section is a single point. I gave it more reason, so I'm just putting more thought into this, I guess. And let me submit the other ones so we can kind of discuss those as well. So this, it is a square. As it gets closer, we see that it is a larger square. All right, so Ryan slices off um, the pyramid parallel to the side other than the base. What does the cross section look like? All right, so let's take a look at this. So he's doing a side cross that. So if we look at it that way, so let's say we're doing this at an angle. Oh, I'm trying to do this. So let me draw it here. So side parallel to the base. Well, we know that the side parallel is a triangle, right? Any other side is going to be a triangle. And let me draw the rest of this here. And if we want it parallel, what's going to happen is here is it's lower, so we're going to get this like flatter side from this side over here, and it's going to kind of expand out like this. So we end up getting this like almost like this, I guess the best way to describe this is this trapezoid. So when he, because we're not cutting it, he is, when he cuts it this way, we get a cross section that looks like a trapezoid. And again, if you guys are having trouble with this, it is really hard to visualize things in a 2D space. Okay, so you can see how it's parallel to the side, it's cutting it here, and it does this. So you're not supposed to get these right off the back. Honestly, I'm probably getting them right because I've done these before. So it's okay to get them wrong. You're just going to start visualizing. Now imagine a cross section. Um, parallel to a side, moving closer to that side. So this is going to move closer to that side. So what's going to happen? So what's going to happen is um, the trapezoid becomes larger. And we'll notice too that this side, the top, uh, with the top base, because unfortunately these are called bases. I know it's at the top, but it's still called the top base. The top base becoming smaller, and the legs, because these are known as legs right here, getting longer. I believe the bottom base also gets bigger. Actually, it shouldn't get bigger because this is all the same. So the bottom base stays the same. So that's why I'm not mentioning the bottom base. So you can see here, this is still the same length. The legs are getting longer, but this top base is getting smaller. They just say it stays a trapezoid. So that's me just overthinking this. All right, so what happens as the cross section moves away from the side that's parallel to? Well, what's going to happen is the trapezoid becomes smaller, legs get shorter, top becomes longer. So you can see it there. See how that top's becoming a lot longer, but these legs are becoming smaller? Ryan cuts off the vertex perpendicular to the base. What does that look like? Okay, so I'm assuming they mean straight down the middle like this, which we would see is a triangle. So this would be this would be a triangle. And I don't know, I guess we could call it an isosceles triangle because both sides would be the same. It might even be an equilateral triangle. It's kind of hard to see. Oh, I see. It's well, we know it's a triangle. I don't know why it said vertex if it's doing it straight down the middle right there. That's weird. All right. Suppose he cuts off the wooden corner not parallel to any face. Oh, so this one it's because it's perpendicular. So suppose it's that one's also going to be a triangle because it's going to be right here on this corner. That's what I was talking about before. This one was just like, hey, perpendicular. So like this would also be a triangle. This would also be a triangle. Yep, so you can see it right there. It's a triangle. So if you're having trouble visualizing this, like for example, I think I said the first time that this where are we? Parts parts D through F. The first time I like looked at this, I was thinking of the triangle, but I wasn't thinking about the fact that it wasn't at the tippy top of this pyramid. So definitely speak about that when you're reviewing this and talking about yourself. Don't just put a number, like explain, write an evaluation about it. You know, what was it that you learned? What was it that you had trouble with? That's part of the growing process is understanding this. All right, so going on to the next one, you can see here how it explains what cross sections are. This one we kind of went into it blank, so like I said, you weren't supposed to get all of them right. It's okay to get some of them wrong and learn from your mistakes. All right, so now we're going to talk about cross sections of a pyramid. Give me a second here. All right, so cross sections of, oops, well, this is a cube. So a cube is a rectangular pyramid, it's just all the sides are the same. So if we look here, what shape is this going to be? Well, you guys saw it, it's a square because this is a perfect cube. This one, if we're doing this one, this is also a square. Now this one, will notice that the base, the top base and the bottom base are equal, but the sides are a little shorter. So that's going to be a rectangle. All right. Submit that. We got it all correct. So let's talk about more complicated ones. Cross sections of shapes. So one of my least favorite things when I was doing geometry was conics. So conics is this idea of cross sections of a cone. Then we can get all kinds of cross sections there. We can get circles, we can get ellipses, which is kind of like an oval. You can get what are they? Not hyperbole, hyperbolas. That's right, hyperbolas. You can get what's the other one called? Parabolas, all kinds of stuff from a cone. So those are interesting cross sections. So let's get into these. They actually give us a pretty good tool to work with here. So it's really interesting to do this, and we're going to be working with it for this part. So let's look at this tool. So cross section flyer. All right, so we're working with this. All right, and this is saying we want it parallel to the circular base, not passing through the tip of the cone. So here's the bottom cone. We want this parallel, so we're gonna want to change the angle a little bit. So we do this. Oh, cool. So that is a circle. So remember how I said conics do all kinds of stuff? And it's actually a double cone that makes the shapes I was talking about. So if I look at this, I'm gonna say, in the table, describe the shape form in this particular one. So in this one, I'm going to say circle. A plane parallel to circular pace passing through the tip. So the first one we didn't want through the tip. So now I'm going to want to raise this line up. I believe that's moving the slice. Yep. And we get a single point. So that should be a single point, just one point. Next one we're going to want to do is plane not parallel to the base, not passing through the base and making an angle with the horizontal less than the slant of the height. So that there's a bunch of complicated stuff there. Oops, let me move this down. Oh my God, I don't want to rotate it. I want to move it down. So what we're doing is we're changing the angle, but we don't want it to cut the base. If we cut the base, see how that's happening right there? So we definitely don't want that. So I'm going to move it up a little bit, change the angle, and you don't want it, so we want it less than this angle side right here. So what we do is we get this little oval, and that's actually called an ellipse. Or let's call it an oval. I don't think we've used the language of ellipse yet. So we're going to call it an oval. So a plane that's greater than the angle passing through the tip of the cone. Okay? So we want this angle greater. And we want it to pass through the cone. So we're going to want to move it up. So give me a second. We're going to move it up to this tip. Gonna change the angle. Oh my gosh. Okay, this moves it up and down. This moves the angle. So we want it up, touching the tip. I want to change the angle. and we want it greater. So what happens is it is going through the tip. We see that here. Um, let me see if I can rotate this a little bit or something. Okay, so this is not touching the tip quite yet. Let's move this. Okay, cool. So what happens is, and we want the angle greater. Oh my gosh. Passing through but greater. We still get a point, it looks like. Let me see if I'm doing that right. Not parallel to the base, okay? Not passing through the base and making an angle horizontal that made slant. Wait, that is less than the slant height. I kept thinking greater. That was not making any sense to me. Okay, perfect. So I want it less than the slant height. So what happens here is we kind of get these two triangles going on here. So not passing through the base. So I don't want it through the base. And I want it less than the slant height. So let me move this around a little bit. Going up. Yeah, I'm still getting a dot here. So the angle is there. It's just, oh, I can't pass through the base. So let me see if I can move that slice. Yeah, if it's not cutting through the base, it's still going to be that dot, it looks like. So not through the base, smaller, I don't, not parallel to the base, and making an angle or so less. So, oh, we already did that one. Oh my gosh. But greater than the slant height passing through the point. I'm still getting a single point here. If it's going through it and it's greater, what's happening is our angle is like this. So it's only going to touch at that single point. Parallel to passing through the point. Parallel to the base. Through the point. All right. So let's submit that, see how right or how wrong I am. And isosceles triangle. I thought it said not passing through the base. Greater than the point, passing through the tip of the cone. Greater than, oh, I guess it didn't mention anything about the base. I was taking this for a while, so we're gonna want to do this. And we're gonna want to move this here. So we see that it is a triangle. So that was just me not reading the directions. I was combining this one and this one together, and that made it a lot harder. The cross-section shapes do not find, what do you find surprising? The isosceles triangle is surprising because the other ones had curves. Also, I didn't read the directions well. It's a good time to be honest. Like, why did you find this writing? Because I didn't read the directions. So now we're gonna be dealing with the cylinder. So what we're gonna do here? Oh, we were supposed to be messing with a cone, not a double cone. That's one of the reasons why this was also getting hard too. I was doing it with a double cone. We should have been doing it with a regular cone. That makes things a lot easier. All right, so now we want to do it with a cylinder. So we're going to want to do all the following things with a cylinder, which for the cylinder part of this, we're going to be doing it in part 2. So I feel really bad leaving it in half of this, but make sure to submit your answers and hit save and exit, and I will finish the rest of this in the part 2 of this video.